All right, so this is number 3 from your review on page 74. And so what this one's asking us to do is just kind of set up a table. And I drew a little quad, like a Cartesian grid, and just numbered the quadrants 1, 2, 3, 4. And so what we're looking for is we're looking to match what they're asking for from the end behavior to which of the functions fit that above, okay? And so extends from quadrant 3 to quadrant 1, okay? So you'll remember a function I can kind of think of right off the bat that extends from quadrant 3 to quadrant 1 is going to be our x cubed graph. So something like this, right? This would be the graph y equals x cubed, okay? Or any other odd function for that matter. And so from what I can tell is if I'm looking for something from that list that I can see is I'm going to put y equals 4x cubed as the function that fits that kind of criteria. And the reason is because we're going to say we have I'll write the reasonings down here so you can kind of see. So we have a positive leading coefficient. Okay, and then in addition, the function is odd, right? And so we know that the end behaviors, if I'm going from quadrant 1 to 3, those are in opposite areas, or 3 to 1, we're in opposite areas of the Cartesian grid, and so we have to have the end behaviors are opposite, and so this is going to be an odd polynomial. So this is an odd degree. Okay, extends from quadrant 2 to quadrant 4. So that would be something like this. Okay, and to me, so we got rid of 4x cubed. To me, it's an odd function, and from what I can see in my list, there's only one other thing there, and it would be y is equal to negative x5. That's the only other odd function that I'm seeing. And remember, the leading coefficient on that negative x to the 5 is negative 1. And so a vertical reflection has occurred. And so we're going to say we have a negative leading coefficient. And so the graph has been vertically reflected. Remember, this kind of looks like this, and it's vertically reflected. And so the degree, because again, the end behaviors are opposite, we're going from 2 to 4, opposite areas of the Cartesian grid, y value wise. It's going to be an odd degree again. Okay. Question 3. So we'll get rid of this one too now. Oh, it looks like we've only got even functions left. Okay. Extends from quadrant 2 to quadrant 1. Okay. From quadrant 2 to quadrant 1 is going to be something like this. Okay. And so that's not totally helpful at the moment. Okay, we're trying to figure out what goes where. And I think it could be either one of those two. Right? So you'll see, like, the only thing that really changes with these graphs, like x to the 4 is kind of like, it gets pretty wide down here. It looks like quadratic, but it's just a little wide. I'll try it over. And all that happens is you start to add more degrees. So this could be something like, x to the 4. And then we could go like x to the 6 just starts to get kind of wider at the bottom, right? Okay, so they both seem to fit these criteria that they're describing in the end behavior, right? So I could say both of them kind of fit in here. So you could say y is equal to 2/3 x4, and y is going to equal to 0.2 x6. Okay, so they're both going to fit in there. You'll notice that their end behaviors kind of go into the same portions of the Cartesian grid, right? They're both pointing in the same direction. That's what it means to be in quadrant 2 and quadrant 1. Okay, the end behaviors. And so we know that it's also going to need a positive leading coefficient because we are not staying in 3 and 4, which would have been a reflection. Okay, so this is a positive leading coefficient. okay, which both of them have. And then also their end behaviors match. And so we're going to say this is an even function. Okay, so both of those fit that criteria. And we could, back to my point, have an x to the 4 or something down in here, but there's nothing in our list to that gives us that kind of end behavior in terms of functions. Okay, so it would need a negative coefficient on, say, let's say y or f of x is going to be negative x to the 4, say. Okay, so there's no functions within our list that fit that criteria, and so we're going to say none for this one, right, from our list. Okay, and that's it for number 3.